everyone and welcome back to SP Learning Labs. So till now you have learned stacks. You saw how elements are added and removed from one side. Now today we are going to learn another very important structure. Today we are learning queues and dequeues. In the last video you learned stack. You saw how LIFO works. Last in, first out. Now today we are going to learn the opposite idea. Think about watching a movie on Netflix. Data is not sent all at once. It comes in order, one packet after another. That is handled using queues. Also, when you stand in a line at ticket counter. First person goes first. That is exactly how queues work. Now, the question is, why do we need queues? Let's take a simple real-life example. You're standing in a line for food. The first person in the line gets food first. New people join in the back. This is fair and this is ordered. That is exactly what queues gives us in programming. First in, first out. Queue follows first in, first out. Let's see an example. Person A comes first. Person B comes next. Person C comes last. Now, who gets served first? Person A. Now, let's look at the code part of queues. First, the basic queue. We are importing Deque class. Queue equals to Deque. This creates an empty queue. Queue.append of 10. This adds 10 and inserts at rear. Queue.append 20. This adds 20 and it also inserts at rear. Now queue.append 30. Adds 30 and inserts at rear. Now print queue.pop left. This removes the front element, returns 10 and first in first out followed. So now let's save it and run it. There we go, we have our output 10. Queue operations. Queue operations are basic actions used to manage elements in queue following first in first out order. NQ means adding an element at the rear end of the queue and DQ means removing the front element. Front is used to see the first element without removing it and is empty checks whether the queue has any elements. All these operations are efficient because insertion and removal happen at opposite ends of the queue. For example, NQ, person joins in a line. DQ, person leaves line. Front, first person, is empty. Check if line is empty. Now the question is, what if we waste space while removing? Now moving on to queue operations. From collections, we are importing Deque. I'm creating an empty queue. Queue.append of 5. This NQs 5 and at rear insertion.
Q dot append of 10. This NQ is 10. Now print Q of 0. This views front and no removal. Q dot pop of left. This removes the front. First it leaves. Now printing length of Q equals to 0. This counts item and it is used for checking if it is empty or not. I am saving it and running it. And there we go, we have our output 5 and the queue is not empty, so it is false.
Circular queue. A circular queue is a type of queue where the last position connects back to the first position instead of wasting space after deletions. The queue reuses empty positions by wrapping around. When the rear reaches the end, it moves back to the front if there is space available. This makes the queue more efficient compared to a normal queue that may leave unused spaces. For example, imagine a round table. After last person, we come back to the first seat. No space is wasted. Now let's go one step further.
Now moving on to circular queue. Taking size as 5. That means 5 slots only. Q equals to none of size. This creates a fixed array. Front equals to rear minus 1. This means Q starts from empty. Taking front as 0, first index is set. Rear equals to 0, rear index is set. Taking Q rear equals to 10, this stores 10. Rear equals to rear plus 1 modulus size. This moves rear, wraps around. Q rear equals to 20. This stores 20. This moves rear again. Now taking Q rear equals to 30. This stores 30. Now printing Q. This shows Q. Printing front index. Front. Printing rear. This shows rear index. Now let's save it and run it. There we go, we have our queue. front 0 and rear 2.
DQ, double-ended queue. A DQ is a data structure where you can add and remove elements from both the front and the rear. Unlike a normal queue, it gives flexibility to perform operations on both the ends. For example, you can insert at front using append left and at the back using append. This makes DQ very useful in problems where elements need to be processed from both sides efficiently. For example, imagine a line where people can enter from both the ends and leave from both the ends.
Now let's move on to DQ. From collections, let's import DQ. I'm creating an empty DQ. Now DQ.append of 10, it adds at back. Now DQ.append of left 5, it adds at front. Let's print DQ. Now DQ.pop, this removes back element. Again, let's print DQ. Now DQ.pop of left. This removes the front. Now let's again print DQ. Now let's save it and run it. There we go. We have our output. First, the whole DQ is printed. Then after removing the pop, the right element has gone and we have the DQ5. And after removing pop of left, we have an empty DQ.
Now let's see an advanced usage. BFS, using queue. BFS means breadth first search, is a method used to explore nodes level by level using a queue. We start from a node, visit it, and then add all its neighboring nodes to the queue. The queue ensures that nodes are processed in order they were added following first in, first out. This helps us explore all nodes at the current level before moving to the next level. For example, imagine exploring a building floor by floor. You visit all rooms on one floor first, then move to the next floor. Now let's apply DQ in a powerful program.
Now let's move on to BFS. From collections, let's import DQ. I'm taking a function here. Def of BFS graph start. Visited equals to set. This tracks visited nodes. Q equals to DQ of start. This starts a queue. While queue, loop until empty. Node equals to q.pop of left. This takes the front node. If node not in visited, this skips the duplicates. Now print node. It visits the node. visited.add of node. This marks as it has been visited. For neighbor in graph, this reads the neighbors. Q.append of neighbor. This is Q's neighbor. Graph equals to A, B and C. I'm giving graph nodes here. Now let's take C. And D. F. Now let's take BFS, graph A. This runs the traversal. Now let's save it and run it. There we go, we have our output A to F.
Sliding window maximum. Sliding window maximum means finding the maximum value in every group window of size k in an array. We move to the window step by step and track useful elements using a Deque. The Deque stores indexes in such a way that the front always gives the maximum element. This helps us find all window maximums efficiently in O(n) time instead of checking each window separately.
Now let's move on to sliding window. From collections, let's import Deque. I'm taking a function here. I'm taking an Deque equals to Deque. This stores indexes only. Taking result, this stores answers for I in range of length of nums. This visits each node. Writing a while condition here, while Deque and Deque of 0 are less than or equals to I minus k. This removes the old indexes. Now Deque dot pop of left, front is removed. Writing another condition. While Deque and nums of dq minus 1 are less than nums of I. This removes smaller indexes. dq dot pop. This back is removed. dq dot append of I. This stores the current index. Writing another condition if I greater than or equals to k minus 1. This marks as window is complete. Now result dot append nums dq of 0. This saves the maximum. Now return result. This returns the answer. Now taking nums 1, 3, minus 1, minus 3, 5, 3, 6, 7, let's print max. I'm taking window size 3. Max sliding window. Of nums and k. Now let's save it and run it. There we go, we have our output. This is the end of the code part.
Best practices. Use queue when order matters. Use deque for both ends. Use circular queue to save space. Think BFS when level traversal is needed. Common mistakes. Dequeuing from an empty queue. Confusing stack and queue. Not using deque when needed. Forgetting boundary checks. Interview questions. What is first in first out? Difference between stack and a queue. When to use deque? How does BFS use queue? Now it's your turn. Implement a queue. Try BFS. Solve sliding window problem. Post your answers, I'll help you improve. So let's recap. Queue follows FIFO. deque allows both ends. Used in many real problems. Order matters in queue. In the next video, we will learn trees. If you found this helpful, like the video, share it with your friends and subscribe to SP Learning Labs. I'll see you in the next one.